For problem number 2, we are asked to estimate the values of these derivatives, and we do not have a function. So we cannot find AT in the interval and cheat by using AROC. However, I'm going to rely on the definition of the derivative that says the derivative is the slope of the tangent line. So I'm going to look at my function, and I'm going to sketch in some tangent lines, just like you did in geometry. So if I'm looking for f prime of 0, I'm going to sketch in a tangent line at 0, and that is a pretty steep slope. I'm going to imagine that this is probably a slope of 1, 2, 3, 4, 5. If I look at the slope at 1, okay, at 1, look, 1 is right up here. So if I draw in a tangent line and find the slope of that, that's 0. If I look for the derivative at 2, I'm going to draw in a tangent line at 2. And let's see, slope of that looks like it's up 1.5, back 1. So maybe negative 1.5. I'm going to write that as negative 3/2. If I look for the derivative at 3, so right over here, I'm going to go to the place on the function. Let's see, something like that. To me, that looks like a slope of negative 1. I'm just doing rise over run there. If I look for the slope at 4, 1, 2, 3, 4. So here's the place on my function where x is equal to 4. The slope of that line, kind of hard to tell. If I extend it, maybe, okay, there we go. It looks like I go down 2 over 3, so negative 2/3, and so forth. F prime of 5, right over here, it looks a lot less steep, right over there. I'm just going to eyeball this. Your eyeballing might be different than mine. Maybe from this point to this point, it looks like I go up 2 and back 1, 2, 3, 4, 5, 6. So maybe that would be 1/3, negative 1/3. F prime of 6, let's see, that was 5, 6. Not very steep at all. I'm going to say negative 1/10. And f prime of 7, it looks like we've turned around and gone back up. And for lack of anything better, I'm going to say positive 1/5.